right, this is part 2 of Unit 8 for Chemistry and Stoichiometry. And part 2 is primarily talking about if we have to go like from mass to mass on our mole map, or if we have to go from like representative particles to volume, or if we have to go from volume to volume, or if we have to go from volume to mass. But you're starting with a different unit. You're having to convert from that unit to moles. You're then going to have to do a mole-to-mole ratio, and then you're going to have to convert from moles back to whatever unit. So the first step, and it's really A, B, C, D in steps. And if you can remember A, B, C, D, you can do this. All right? So you have to have a balanced chemical reaction, and you have to go ahead and identify what you know and what you're looking for. So identify your knowns and unknowns. Then you're going to convert from, and I'm doing this as a mass to mass, so I'm going to convert from the given mass to moles by dividing by my GFM. Remembering that the GFM is found by the sum of all the elements or all the atoms in a compound. Then once you get that given value into moles, you'll convert moles of the first substance to moles of the second substance by again using a mole ratio. And that mole ratio will be using the coefficients from the balanced equation. So you'll put the number of the coefficient of moles wanted over the number of the coefficient of moles given, and you'll create that as your next ratio. And then finally, you'll convert the moles of the second substance, or your unknown substance, into grams by multiplying by its GFM. Okay? So, let's do some examples. Calculate the number of grams of solid sodium oxide that will be produced when 115 grams of solid sodium react with oxygen. So, we first have to write a balanced chemical equation. I will tell you on your test, you'll be given the chemical equations. You sometimes will have to balance them, you sometimes won't. But if we write this reaction, it is Na plus O2 yields Na2O. And then we balance it by putting a 4 in front of the Na and a 2 in front of the Na2O. Okay, so that's the first part. Then we also have to identify our knowns and unknowns. Well, we're given 115 grams of solid sodium. So that goes right here. We're looking for the number of grams of solid sodium oxide. So we're looking for this of sodium oxide. Okay, so the only thing about this excess of oxygen, O2, just really means that there's more than you need, okay? So there's more than enough. So just so you're aware. Okay? Then our next part is to convert the given mass to moles by dividing by its GFM. Okay? So to do that, we will look up sodium on the periodic table, which rounds to 23.0 grams. We'll put it on the bottom, because we're dividing, and we'll put 1 mole on the top. All right? So that's part B. Once we do that, we've converted from grams to moles. So we've gone from the circle of mass on the left side, and we've followed over to our moles of given in the middle of our mole map. Now we're to create a mole-to-mole ratio. So we put the moles of the given on the bottom. So moles of sodium would be 4 because the coefficient's a 4 in the balanced reaction. And on top, we'll put moles of sodium oxide. And we'll put a 2 in front of that because the coefficient's a 2. Now that completes step C, and we'll finish with part D, and that's to convert the sodium oxide from moles back into grams. So we'll have 1 mole on the bottom, and for every 1 mole, we have the GFM. So we look up sodium, which is 23.0 times 2, and then we'll look up oxygen, which is 16.0, and it'll be 1. So we'll add those values together and come up with 62.0. Once we've done this, we've completed and set up our entire stoichiometry set. This is as complicated as it gets, okay? And you'll just have to do this kind of process over and over and over again. But all you'll do now, it's really dimensional analysis of multiply across the top and divide by everything on the bottom. When you do that, you end up with 155 grams of sodium oxide. Okay? So let's do another. How many grams of oxygen are required to burn 13 grams of C2H2? So again, we have to write the balanced chemical equation. Here it is. Okay? Then we also have to identify our knowns and our unknowns. So we're starting with 13 grams of this, and we're trying to solve for the grams of this. That's part A. Then the next thing is to start with what you're given and convert from whatever units it's in into moles. This is given to us in mass, so to convert from mass to moles, we divide by the GFM. So we'd look up carbon. Carbon's 12.0 times 2 from our periodic table. Hydrogen's 1 times 2. We would then add them together, which would give us 26.0 grams. We would put that on the bottom because we're dividing, and we would put 1 mole on top. That finishes part 2. Part 3, or step C, would be to make the mole-to-mole ratio. Put your moles of given on the bottom and the moles of what you want to find on top. The moles of our given we get from the coefficient. In front of C2H2 in the reaction is a 2, so we'll put 2 moles on the bottom. And we want to find oxygen, and in front of the O2 is a 5, so we'll put 5 moles of oxygen on the top. That completes step C. Finally, for step D, we want to convert from moles of this second substance into whatever value we're looking for, which is grams. So we're going to multiply by the GFM. Oxygen is 16. 16 times 2 is going to give us 32. So we'll put 1 mole and 32.0 grams on top. And again, everything will cancel out nicely. Grams of C2H2, top and bottom, moles of C2H2, top and bottom, and moles of O2, top and bottom. So all we're left with is grams of oxygen. Multiply across the top, divide by the bottom, and you end up with 40.0 grams of O2. Okay? So I can do a bunch of examples of this. Okay, we can use the same reaction again. I can start with 13 grams of C2H2, but I can look for grams of C2 or CO2 instead. So, I mean, we can do the same process over and over and over again. We divide by the GFM, convert it into moles, do the mole ratio by looking at the coefficients, and then convert from moles back to grams by multiplying by the GFM. It is the same process over and over and over again. And we end up with 44.0 grams. Okay? I could also look for how many grams of water, because it asked me for both. So again, I just set it up. I'd have the same G divide by the GFM. Then I'd set up my mole ratio of 2/2, because now I'm talking about water. And then I would have to use the GFM of water, which is 18, multiply by across the top, divide by the bottom, and find out that it's 9.00 grams of water. So again, like I said, it's the same process over and over. Okay, we could actually use our answers from A and B to show if this equation obeys the law of conservation of mass. Okay, if I said that my mass of my reactants was 13 and 39.9, that would say that my mass of my reactants was 52.9 grams. If I then look at my two answers previously of 43.9 grams and 9 grams, those also add up to 52.9 grams. Law of conservation of mass is satisfied here, so it is obeyed. Yay, mass is conserved. All right. So we could also go to different things. So I could start with molecules and want to go to grams instead. So molecules is actually representative particles. So I would start with representative particles and I would go through my mole map that way. So I would start with my moles or molecules of HF, and for every one molecule, or for every one mole, I have 6.02 times 10 to the 23rd molecules. So I'm going to divide by that to cancel out molecules and get into moles. That is step B. Now I have to do my mole ratio. So there's 2 moles of HF from the coefficient in the reaction, and there's 1 mole of SNF2 from the coefficient in front of SNF2. Then I want to go from moles to grams, so I'm going to multiply by the GFM. So I'd look up the mass of SN, I'd look up the mass of F, I'd take the mass of F and multiply it by 2, and then add it to the mass of SN, and I would end up with 156.7 grams of SNF2. Multiply by everything across the top, divide by everything on the bottom. Remember, when you have times 10 on a calculator, you're going to use an EE button, which is right on our calculators in class. It's right next to the letter A, and that stands for times 10. And you would end up with an answer of 966 grams of SNF. So this is just doing it a different way because we didn't start with grams. We started with representative particles, but we still did the same steps. So I could also do it with liters. Okay, I could start off with grams, but convert to liters. So if I start off with 23.4 grams of SN and I want to go to liters of H2, I would start with grams, but I would have to divide by the GFM to get it into moles. Then I would make my mole to mole ratio, and then I would convert from moles to liters. I know for every 1 mole, there's 22.4 liters. Then I'm canceling out grams of SN, top and bottom, moles of SN, top and bottom, and moles of H2, top and bottom. I'm ending up with liters of H2, multiply across the top, divide across the bottom. All right? Because that it's the same process over and over and over again. Same reaction, but I could start with liters and want to find molecules. So if I started with liters, I know there's 22.4 liters for every 1 mole, so I would divide by 22.4. Then I would set up my mole ratio, so I'd put 2 moles on the bottom and 1 mole on the top. And then I know for every 1 mole of H2, there's 6.02 times 10 to the 23rd molecules. So again, it's about following the mole map. Start with what you're given in units, get it to moles. Once you get it in moles, create a mole-to-mole ratio. So you can talk about the 2 different substances in your equation, in your reaction. And then get it from moles to whatever you want that final unit to be. This would be 1.08 times 10 to the 24th molecules. Okay, that's really doing those multi-step conversions or multi-step stoichiometry. So this should help you look at all of those and how they work. They always only have 3 steps. You start with what you're given, convert it to moles. Then you do your mole-to-mole ratio, and then you convert it from moles back to what you want. That's the maximum amount of steps that you will ever end up with in these multi-steps. You could have fewer steps, but you won't ever have any more steps than this. Hope this helps. You really should work on, again, worksheet number 2 or worksheet number 3 on your classwork, which remember all the work and all the answers are posted for those. And you should be working on part 2 of your homework. Okay, those are all that go along with these. Hope this helps.